Hello to everyone. This is Shantan Kumar, Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Subject is matrices and calculus. Today we are going to discuss the topic on the triple integral in the constant limits. The triple integral in constant limits, these are under the category of the multiple integrals. Previous lectures we discussed based upon the double integration. Under the double integration, whenever the limits are given the constants, then how to find the solutions we discussed properly. And second method, whenever the double integrals, the variables are given, then how to find the solutions we discuss. And the third case, under the double integral, whenever the limits are not given, that means the region is given, that means the equations are in the format, then how to find the solutions with the help of the parallel to x-axis and parallel to y-axis, and based upon the concept, we find that properly. And after that, we discuss finally whenever under the double integral, the change the order of integration, the problems are completed. And today we are going to discuss under the triple integration, that means the three integrations are involving, then how to find the solutions that under the categories are the limits are constants. Before going to discuss, that is what is the meaning of the triple integral, and again how to find the solutions under the triple integral. Generally the triple integral is nothing but the integrals of a function of three variables over the region in R3 are called the triple integrals. That means whenever involving, that is a triple integration, that is a three integrations under the region, that is R3 is called the triple integrations. For example, here the triple integral of a function of three variables, that means based upon the given function which is involving x comma y comma z over the region R in R cube is, that is triple integration f of x comma y comma z into dv, and is equal to the triple integration that f of x comma y z dx dy dz, and similarly the triple integration that f of x comma y comma z dy dx dz, and similarly other one also the triple integration f of x comma y comma z dz dx dy. That means here the inner function is with respect to x, and again here inner function is with respect to y, and similarly the inner function is with respect to z. That is the meaning of whatever the inner limit, that is with respect to variable, that is x, means we need to first integrating with respect to x, and after with respect to y, and with respect to z. For example, dy dx dz, that means first integrating with respect to y, and second is with respect to x, and after with respect to z. That means we need to follow that inner to outer according to one by one the variable with respect. And this is especially whenever the limits are under the constant limits. For example, the limits are variable, that means depend upon the variable inner limits like upper limit and lower limit, and we need to follow the instructions. But today class we are going to discuss under the triple integration, the limits are the particularly the constants, then how to find the solutions. Here, for example, the triple integral with constant limits, that means the triple integration here, the integration a to b, integration c to d, and integration m to n, and these are particularly the limits are constants because of there is no variable. The function is in terms of x y z, that is a given function f in terms of x y z, and again with respect to dz dy dx. That means the limits are constants, the inner variable is with respect to first is z, that means we need to do that integrating with respect to z, that z limits are m to n, the lower limit is m, the upper limit is n. Now we need to do that integrating with respect to first z, and again the remove that next that x and also y. That means we need to do that first integrating with respect to z, whatever we integrating with respect to z, that is treated as in terms of g of x comma y, that is a function of g of x comma y. That means after replacement of z limits, after integrating applying that z, that equations are in terms of x comma y. That is a function. And getting the function that g of x comma y, we need to replace in the other than the rest of the double integral. That means here under the double integration we need to replace g of xy into dx dy. And here also again the inner limit is with respect to y. That means we need to do that with respect to y's, and again after that with respect to x. And similarly, for example, these are the limits, the triple integrations, and again here the function is f of x comma y comma z, and again here the dx dy dz dy. While we are going to observing here in this, the limits are particularly constants, but the inner variable is with respect to x because of it is a dx. The dx means we need to find out with respect to x integration. The limits are under the x limits are m to n. Now we need to do that first with respect to x. Whatever integrating with respect to x, that values you get, and again the replacement of upper limit x and the n, lower limit and upper limit. This function is treated as in terms of g of yz. That means g of x yz, again that values we can replace in terms of that first integration, that is inner part. And again here once again now integrating inner limit is with respect to z. The z limits are c to d, and again after calculation we integrating with respect to dy. And similarly, for example, the function is dx dy dz, and here also the limits are constants. First is the inner is x, second one is y, third one is z. Now our target is to find out integrating with respect to x. After getting this one, again you need to find out with respect to z of y. Again after that simplification, we need to integrate with respect to z. This is a clear procedure to find the solution under the triple integration, that is whenever the limits are the constant limits. For example, and here the function is f of x comma y comma z dz dx dy. Then the meaning of here also, first integrating with respect to z, the z limits are, the inner limits are m to n. We need to do that integrating with respect to z. After getting this value, again we need to replace here next with respect to dx and after with respect to y. That is the meaning of here. Clearly we understood how to find the solutions under the triple integration. The limits are the constant limits. That means when the conclusion of this one, the under the triple integrations, whenever the limits are constants, then we need to follow that inner to outer that depend upon the given variable with respect to. For example, integration minus 1 to 1 and integration 0 to 2, integration 0 to 1. Here the function is f is a function that is xz minus yq into dz dy dx. Here the limits are, that is a constants, moreover under the triple integration, and based upon the previous slides, here under the triple integration the limits are constants. We need to follow any order, but here the inner variable is with respect to z given. That means we need to do that integrating first with respect to z. Now we need to assume that it is I is the integral part is equal to the triple integration xz minus y cube into dz dy dx. Now our concept is the inner is the variable with respect to z. Now we integrate with respect to z first, and again after with respect to that y, and third one is with respect to x. That is the meaning of here. The under the triple integration the limits are constants. We need to find the solutions. While we are going to do that, first with respect to z, the integration with respect to z on the function xz is equal to, that is x into z square by 2 minus y cube is a constant, we need to take out common. The rest of the term is 1. With respect to z is a z value. That is the meaning of here. That is a here x into z square by 2 minus y cube into z. And here we need to replace at z is equal to, given the limits are 0 to 1. Here by replacement of upper and lower, the term we should be, it is a x by 2 minus y cube is the upper limit, minus lower limit is clearly that is a 0. Now again we need to do that integrating with respect to y. And again here after that simplification next to, that is integrating with respect to y. Now the integration that x by 2 with respect to y is a x by 2 is a take out common. The 1 with respect to y is a y, that is x by 2 into y minus y cube integrating is with respect to y, that's minus y power 4 by 4 is a value. Therefore x by 2 into y minus y power 4 by 4, the limits are y is equal to, that is 0 to 2. Now again while we are going to replace upper and lower, the limits are, it is a y is equal to upper limit is 2, that is a x minus 4 minus 0 by after replacement of upper and also lower. Because of in this y is equal to the upper limit is, that is 2, that is 2 to cancel, minus here also the 2 power 4, and again that after that simplification you obtain that is a 4 only, and it is a minus 0 into dx. Now again we need to integrate it with respect to dx. While we are going to observing here that this function is x minus 4 is an even function, in between the limits are minus 1 comma 1. That means we know that one of the important formula, whenever the function is here minus c to c, the function total is it is an even function. We need to change, that is 0 to c into f of x into dx is the value. Based upon this one, here the function is total, it is a even function. Therefore we need to change that, that is 2 into integration 0 to 1, it is x minus 4 into dx is the value. And based upon this one, here the integration is 2 into x square by 2 minus 4x. The limits are 0 to 1 value. That means here also the after replacement of upper and lower, the value it should be clearly, that is a minus 8. Because of here the 2 is cancelled, it is upper limit is 1 minus 4, and again here it is 2 into x square by 2 is the x square minus that is 8x. The limits are, it is clearly 0 to 1. The upper limit is 1 minus, it is a like x minus 4, it is 1 minus 8. So it is a x square by 2. Yeah, sorry, it is a some x square by 2. The 2 is cancelled. It is a x is integration x square by 2 minus 4x. It is sorry minus 7. But okay. Anyhow, we need to check it that based upon this is the property only. The problem is whenever the function is sorry, it is the function is, it is not even. It is whenever the function is, it is a even function only, it is a formula. But here it is a function is, it is a odd function. Based upon the property integration of minus c to c, that is f of x into dx, the value is 0 whenever the function is odd function. And again while we are going to observing here that one of the condition is, it is integration minus 1 to 1 x into dx minus 4 into integration of minus 1 to 1 into dx. Here this first term it will be, it is a odd function, and based upon the odd function by using the property the value it will be 0, and minus that 4 into that, here it is a function is a even function. Here based upon the even function it is a 2 into integration of 0 to 1 into dx, and here that 4 into 2 is nothing but minus 8. That function is a x minus, it is a upper x integration, the limits are x is equal to 0 to 1. Therefore, minus 8 into that is 1 minus 0 is equal to minus 8. Therefore, it is a clear solution only. Here, just only we misunderstand here the integration is a minus 1 to 1 x minus 4 into dx. We need to split into the two parts. First part is clearly it is an odd function, and second part it is an even function. And based upon that, we know that the formula by using the integral that in between minus c to c, the function is a even function, it should be changed the 2 into 0 to c. But if the function is a limits under the minus c to c, the function is odd function, the value it will be 0. And based upon here, applying like the two formulas, here the final solution it will be clearly it is a minus 8. Now we need to discuss the integration 0 to a and 0 to b and 0 to c. The function is x square plus y square plus z square into dz dy dx. While we are going to observe here, the problem is clearly under the triple integration with respect to that is xyz, the limits are constants. But here, not mentioned that particularly these are the limits for particularly specifically. We need to assume that the inner limit is first is with respect to z, and after that with respect to y, and next is with respect to x. While we are going to do that according to inner to outer, first we need to integrating with respect to z. Therefore, the integration with respect to z is a x square is a constant. Then we need to take out common outside, and again here here also we need to do that integrating that depend upon any choice, no problem, because of the limits are constants. We need to give the priority for any order that depend upon the function, because of the limits are constants. By interchanging any limits with respect to like x y z, we obtain the final any solution. Because of already we discussed in the previous session, whenever the limits are that is a constant a to b and again c to d, that is f of x comma y into dx dy is equal to integration of that is a c to d and integration of a to b, that is f of x comma y into that is a dx dy. This is the proper, this is applicable based upon this one. Under the triple integration also, we need to assume any order by interchanging that x, y, z or z, y, x, whatever it may be. But here, we did according to integrating with respect to first x. Therefore, while we are going to do that integrating with respect to x, that is x cube by 3 plus y square into 1 integrating is with respect to x is x plus z square integrating with respect to 1 is that is also x. Now again we need to replace at x is equal to that is 0 to c. After replacement of here, x is equal to upper limit is c and lower limit is 0. Therefore here it is a c cube by 3 plus cy square plus cz square into dy dz. Next again we need to integrating with respect to it is a y. Therefore here treated as a other terms which is a constants. Therefore c cube by 3 is a constant and remaining the 1 is a with respect to y is a y plus c in is a constant. Y square integration is a y cube by 3 plus cz square is a constant. That integrating with respect to 1 is a y, and again here based upon with respect to y we obtain this is the function. Now again we need to replace at y is equal to 0 to b, that is upper limit and lower limit. Here again by replacement of upper and lower limit we obtain this is the function. Now again we need to do that integrating with respect to z. While we are going to do that with respect to z, it is clearly c cube b by 3 is a constant, and again 1 with respect to z is a z plus cbq by 3 with respect to z, 1 is a constant with respect to z is a z plus cb is a constant, that z square integrating is a z cube by 3. Therefore now we need to replace that 0 to a. By replacement of at z is equal to a and again the lower limit is z is equal to a. According to after the replacement of upper and lower, the value it will be that is a c cube ba by 3 plus cb cube a by 3 plus cb a cube by 3. If you want to take out common, again it is a abc like that by 3. Therefore abc by 3 into that is a square plus b square plus c square is a final solution. Similarly, for example, here also the problem is under the triple integration, with respect to z, y, x. Here also the problem is not given any particular order. These are the limits. That means we need to consider any order that depend upon the given equations, that depend upon the function, depend upon the limits are under the constants. While we are going to assume here, that is for example, if I take that first is a integrating with respect to z, that means x is treated as a constant, then 1 with respect to z is a z, plus y is also constant, the respect with respect to it is a 1 with respect to like the z, that is also yz, and in z integrating is a z square by 2, and again the limits are under z is equal to 0 to c. Now again we need to replace at z is equal to that upper limit is c and lower limit is a. While we are going to replace that upper and lower limit, here the problem it will be xc plus yc plus c square by 2 into dy dx. Now again we need to do that with respect to y, because of second inner is a y. That means once again if we do that integrating with respect to y, that means xc is a constant, that means xyc, and yc is the y, c is the constant, that means y square by 2, plus c square by 2 is a constant, that is with respect to y is the 1 is 1 with respect to y is the y. Therefore the integration is xcy plus y square c by 2 plus c square y by 2 is the value. The limits are here y is equal to 0 to b. Now again we need to replace at y is equal to the upper limit is b and lower limit is 0. Therefore after replacement of upper and lower in presence of y, the value it will be like it is a xbc plus b square c by 2 plus bc square by 2 is the value. Now again we need to do that with respect to x. Here we are doing that with respect to x is nothing but the first term is a bc into x square by 2 plus b square c by 2 is a constant, with respect to x is the first one is the x, plus bc square by 2 integrating with respect to 1 is also here x. Therefore the solution will be here also x square bc by 2 plus b square cc x by 2 plus bc square x by 2. The limits are under here x is equal to 0 to a. Now again we need to replace at x is equal to upper limit is a and lower limit is 0. Therefore the solution will be a square bc by 2 plus ab square c by 2 plus abc square by 2. Now again if we need to take out common abc by 2, the value is abc by 2 into a plus b plus c is the required solutions. That means the conclusion of under here, whenever the triple integration or double integration, whenever the variables are given, the limits, we need to strictly follow that. But if the limits are given any constants, we need to consider any order, but we need to give the priority for the inner to outer while we are going to do that integrating with respect to that conditions. Similarly, evaluate integration 0 to 2 and 1 to 3, 1 to 2, x into y square z, dz, dy, dx. That means we need to assume that the integration it is I. Now we need to integrating with respect to it is a z. Because of the inner is the z, it is not given particularly any limits. These are the like mentioned, not mention any limits that with respect to variable. Therefore, we need to integrate with respect to z. And here the product is given, that means we need to take out common xy square is a common, take out common, the z is integration is a z square by 2. Therefore that z square by 2 into xy square into dy dx. That means again we need to replace that upper and lower in place of z. That is a upper limit is 2 square and lower limit is 1. That means 4 minus 1. That means that is a 3 by 2. Therefore we need to take out common 3 by 2 is outside, and again here xy square is a dy dx. Now again we need to integrating with respect to y is nothing but that is a y cube by 2, y cube by 3. Because of y square is already with that variable, the integrating with respect to y is a y cube by 3. Now again we need to replace y is equal to 1 to 3. Here the limits are 3 cube minus 1 by 3 into x dx after replacement of upper and lower. Now, after that simplification, it is a 26 by 4 into x square, that is a 0 to 2. That is also after applying the integrating with respect to x. Then we need to replace it x equal 0 to 2. The solution it will be 26 is the final solutions. And again, now for example, integral 0 to 1, 0 to 2, 1 to 2, y x square z into dz. Here it is clearly given, the first one is with respect to x and second one is with respect to y, the third one is with respect to z. That means we need to follow the inner to outer. That means we need to do that integrating first is a z. That means yx square into z square by 2, because of z integration is a z square by 2. The limits are upper limit is 2 and lower limit is a 1 is the value. While we are going to do that, it is a upper and also the lower limit. The value it will be 2 square minus 1, that is nothing but 3 by 2. Take out common 3 by 2 outside. Then the rest of the values are y. The integrating with respect to y is a y square by 2. And again, the limits are 0 to 2. Once again, we need to replace that y is equal to 2, upper limit, and lower limit is 0. Therefore, 4 minus 0 by 2 is nothing but numerator 4 and denominator 4 both are cancelled automatically. The rest of the thing is 3 into integration 0 to 1. Here, the 3 into integration 0 to 1, the integration x square into dx. The integration of x square is nothing but, once again, it is a x cube by 3. Therefore, it is a 3 into x cube by 3. Sorry, it is a 2 to cancel. That is x cube by 3. 0 to, that is a 1. It is a, like, yeah, it is 3 into x cube by 3. That is 3 is also cancelled. 1 minus 0. Therefore, the solution it will be, it is actually it is 3 is also required. And again, the solution it will be 1 minus 0. It is nothing but 1. It is clearly showing the solution, it is also the 1 value. Now, for example, the integration is 0 to 1, 0 to 2 and 0 to 3. The function is not given any function. That means we need to assume that function is y and dz dy dx. Now, we need to do that with respect to first is a z, because of inner is a z. Therefore, 1 with respect to z is that integration is a z value. The upper limit is 3 and lower limit is 0. Therefore, 3 is a first one, the inner part of that after replacement of upper and lower, and again into, and again the rest of the thing is here y, and again here also the integration 1 is a y, that is upper limit is 2, lower limit is 0. That means 3 into 2 is a 6 after replacement of upper and lower. Now it is integration with respect to 1 remaining. The integration it is a 6 into 0 to 1 into dx. Therefore, that is 6 into, that is x, that is 0 to 1. Therefore, it is 6 into 1 minus 0. The solution it will be 6 is the required solutions. Now, again, for example, the problem 1 by 8 under the triple integration 0 to 2, 0 to 2, 0 to 2, x, y, z, dz, dy, dx. While we are going to observing here, same, the limits are under the constants, that is a triple variable, that under the three integrations. First, it is the inner part is, that is a dz and dy and dx. Now, we need to do that integrating with respect to z is the first one. The limits are under 0 to 2. Therefore, 1 by 8 into, that is integration, that is a z square by 2. The upper and lower, that is a 2 square by 2. That is a 4 minus 0 by 2. That is a 2 is cancelled. That you obtain that 1 by 16, because of under here x y z square, that is a 4 denominator here, and again here x y, that is a y square by 2, and again here also 1 by 8. That after replacement at y is equal to 2, that is a 4 by 2. Therefore, the solution it is clearly 1 by 2 into x square by 2, that's 0 to 2, and here also 1 by 2 is 1 by 4. The upper limit is 4. Therefore, the solution will be, it is a 1 value. Now, for example, here integration 2 to 3 minus 1 to 4 and 1 to 0, 4x square y minus, that is z cube into dz dy dx. And here the first one is integrating with respect to z, and it is a y and it is x. Because of here also not given that particularly any limits, these are like not mentioned. Therefore, we need to assume that in a order, the first limits are z is equal to 1 to 0 and y limits are minus 1 to 4 and x limits are 2 to 3. While we are going to give according to this is a priority, why first the integrating with respect to z is a 4x square y is a constant. The integrating one integration is a z. Therefore, 4x square y z minus z cube integration is a, that is a z power 4 by, that is a 4 value. Therefore, according to this one, it is a 4x square y z minus z power 4 by 4. The limits are 1 to 0 because of given the limits are the lower to upper, that is 1 to 0 and dy dx. Now we need to replace y limits, that is a z limits. Upper is 0 and lower is 1. 1 by 1, the replacement of upper and lower. The first one is z is a 0, that means to the term is 0. And again, after the replacement of upper and lower, that is a 1 by 1 successfully, we obtain that 1 by 4 minus 4x square y into dy dx. Now again, we need to do that with respect to y is inside. Therefore, the integration part of 1 by 4 is 1 by 4y minus 4x square y is the integration y square by 2 and 2 is also cancelled. Therefore, 1 by 4 into y minus 2x square y square into, the limits are minus 1 to 4 into dx. Now again, we need to replace in y is equal to, that is 4 and lower limit is minus 1. Here we obtain that 5 by 4 minus 30x square into dx. Now again, we need to further, finally that is with respect to x, that is 5 by 4x is the integration 5 by 4x minus 30 into x cube by 3. Therefore, 30 into x cube by 3 is nothing but that is a 10. Therefore, that is a 10x cube is the value. Now again further, finally we need to replace that x is equal to 2 to 3. Therefore, it is also the final solution, it will be minus 755 by 4 is the solution. These are the some problems based upon under the triple integration. The functions are which is involving in terms of x comma y comma z, and moreover the limits are under the constants limits. We need to follow, these are the some conditions, find that. For example, like this is the one different type of the problem, but here the function is not xyz. The function is given in terms of, that is r comma theta comma phi. But in our mind, we need to assume that these are the, like if it is a xyz, these are the three different variable. Here the inner to outer, it is also treated as, the first one is r and second one is theta and finally it is a phi is the value. Same like according to the previous problems, we need to integrate it with respect to r. It is a sin theta is a constant. That means r square integration is a r cube by 3 is a value. While we are going to do that, according to here, replacement of r cube by 3, the upper limit is 1 and lower limit is 0 and d theta d pi. And here upper and lower, the value is 1 by 3. We need to take out common outside. Therefore, after take out common 1 by 3, the rest of the thing is 0 to pi and 0 to pi by 2 sin theta and d theta d pi. Now again, we need to further with respect to theta. Therefore, integration of sin theta. That means, as we know that, that is a minus cos theta. Therefore, replacement of if theta is equal to, that is 0 and pi by 2. Therefore, after replacement of 1 by 1 upper and lower, the value it will be, that is a 1 into d pi. Because of cos pi by 2 is the value is a 0. That means minus of minus 0 is a something, minus of 0 is a like 0 only. And minus lower replace, that minus of minus is the place, that is a cos 0 is 1 value. Therefore, the value it will be 1 into d pi. And again, we need to with respect to pi, here 1 with respect to pi is like pi is a solution, and that is a upper limit 0 to, that is a pi and lower limit is 0. The value it will be, that is a pi by 3 is a, that is a final solution. Because of here 1 is nothing but it is a pi. The already 1 by 3 is existed. The limits are 0 to pi. Therefore 1 by 3 into that is a pi minus 0, it will be clearly pi by 3 is the final solutions. That means we are not going to bother about here whenever under the double integration or triple integration. That means under the constant coefficients we need to give the priority according to any order, but we need to give the priority for that inner to outer is a compulsory. For example, the limits are here also the triple integration. The limits are 0 to 1, 0 to 2 and 1 to 2. And moreover, here also the constant limits under the triple integration, three variables. That is a correspondence like 1 by 1 z, y, x. And here first is a z and y and x. First we give the priority for z, that means z square by 2, because of xy is a constant, that is into z square by 2, the upper and lower. Then we need to replace that upper is equal, that is 2, and lower is equal, that is a 1. Therefore the solution it will be here x into y, that is z square by 2. The limits are 1 to 2. That means it is a 2, it is a xy into that is a 4 minus 1 by 2, that is a 3 by 2. And again here further 0 to 1 and 0 to 2, and again xy into dy dx. And again we need to do that with respect to y, and similarly it is also y square by 2. And again similarly upper limit is y is equal to 2 and lower limit is 0. And again finally after replacement, like after the simplification, again we need to do that integrating with respect to x. The x limits are here x is equal to 0 to 1, and these are the particularly y is equal to 0 to 2. While we are doing according to these are the some procedures, we obtain the solution is finally 3 by 2 is the solutions. For example, here the problem is 0 to 1, 1 to 2 and 2 to 3, and xyz dz dy dx. And here also here the integrating is first with respect to z, that means the z limits are 2 to 3. And again after that with respect to y, that means y limits are 1 to 2. And again finally the limits are that with respect to x, that means x is equal to 0 to 1. First we need to integrate with respect to z, that means that is a z square by 2. And again here also same like a previous example. First according to consider these are the intervals limits, particularly with respect to we need to do that integration. Here first is z, that is a z square by 2. And again similarly upper and lower, and finally one by one all the like z like, and after that y, and again similarly x. The final solution it will be 15 by 8 is a solution. And similarly like this is also one important problem, like here, some different integration 0 to 1, 0 to 1, 0 to 1, e power x into e plus e power x plus y plus z into dz dy dx. And here also not given any particular the limits, but under the variables are x y z, the limit treated as like three constant terms. Therefore we need to priority for z is equal to 0 to 1, and y is equal to 0 to 1, and x is equal to 0 to 1. And based upon this one, we need to first integrate with respect to z, the inner to outer. Therefore while we are going to do that integration, that is inner, it is we need to assume that 0 to 1 and 0 to 1 and 0 to 1, the function is e power x plus y plus z. First we need to divide like that, e power x into e power y into e power z into dz dy dx. And we need to do that integrating with respect to z, y, x 1 by 1. After replacement of 1 by 1, that is upper and lower, the value should be that is a e power, that is a e minus 1, I think whole cube is a value. And in other terminology, for example 0 to 1, it is e power x, and again integration 0 to 1 e power y, and integration 0 to 1 e power z. Here first is with respect to dx and dy and dz. The first term it is e after replacement of upper and lower, it is 1 e power minus 1, and second one is also e minus 1, and third one is also that is a e minus 1. Therefore based upon this one we obtain the solution is clearly e minus 1 whole cube is also in shortly method we need to find out. And again similarly it is also based upon the previous example in the previous condition. While we are recall the previous problem, easily we can say the solution it is based upon 0 to 1, and again it is 0 to 2 and 0 to 3, And then again, the given problem is we split into like that e power x and e power y and e power z. First is dx and dy and dz. Therefore, it is x is equal to 0 to 1 and y is equal to 0 to 2 and z is equal to 0 to 3. That means the given problem, we need to assume that I, while we are going to do that, finally the solution without simplification, we can say such type of this problem, especially the problem, it will be e power q minus 1 and again e square minus 1 and again e minus 1. This is the final solution, maybe. Yeah, exactly. It is e minus 1 and e square minus 1 and eq minus 1. It is the final solution. Because of, as we know that integration of e power x like that, e power x only, the upper limit is e power 2 minus e power of 0. That e power 0 is nothing but 1. Based upon the simple logic, it is the solution is e minus 1, e square minus 1, eq minus 1 is the final required solution. Same here also, but we can't say this is the problem directly without doing like a problem. We need to do that according here. The integration, it is a dz and again dy and dx. First, we give the priority for z is equal to and y is equal to and x is equal to. First, according to that, integrating with respect to z, here that z is nothing but x y is a constant. The first term, it is a x y z, and again the second term y z. We need to do that integrating with respect to z. That means z square by 2, and the third term is a zx already existed x. That means x into z square by 2. The limits are that is equal to z is equal to 0 to 3. And again, similarly, after simplification, again we need to further with respect to y, and again replacement of it is, these are the z is equal to, and these are the y is equal to, and these are the x is equal to. And again, first we need to replace with respect to z, like, and again the upper and lower, the 3 to 0. The second one is integrating with respect to y, and again with replacement of y is equal to, that is upper is a 2 and lower it is 0. And again, finally, we need to do that integrating with respect to x. The upper limit is 1, the lower limit is 0. By doing according to all the steps, we get obtained finally the solution is a 33 by 2 is the final solution. Like these are the in the, under this class, like the problems are like under the triple integrations, the variables are like x comma y comma z. That means with respect to x y z, the limits are especially under the constant terms. We need to give the priority like into inner variable with respect to that outer variable with respect to. That means whenever particularly these are the not mentioned, like such type of the variables are not mentioned, the limits, then based upon that give the priority for like inner to outer. And again, under the double integration also same like this. Whenever the double integration, the variables are like x comma y or something y comma z or comma x comma z. That means any two variables are also like under the double integration, the limits are constants. We need to follow any order. There is no difference, especially under the given function is a continuous function. We can change the limits, like interchange that x to y or y to x. We can find the solution. We obtain the same solution. And similarly, like any number of like more integrals are also, whenever the variables are like limits are particularly the constant terms, we need to find the solution. These are the concepts. Moreover, we need to remember that to do the priority for the inner to outer. Like this, any problems are given, we need to do the find the solution like this. And for example, like this also, like 0 to 1 and 1 to 2 and 2 to 3, x plus y plus z, dv dz dy dx. Based upon this one also, that first is z is equal to 2 to 3, and second one is y to y is equal to 1 to 2. And again, based upon that x is equal to 0 to 1. That is the meaning of here. The inner to outer is z first with respect to, and again after replacement of like with respect to z, we need to replace the z limits upper and lower. And again, next is with respect to y, the limits are y is equal to 1 to 2. And again, finally, we need to integrate with respect to x. Then limits are x is equal to 0 to 1. We find the solution one by one, that is inner to outer. Here also, while we are going to according to same this condition, we obtain the final solution is here 9 by 2 is a final solution. If any like under in this lectures, and again we give the information, like give the feedback under given the slides. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.